video going through mastering Bitcoin. And in this video, we're going to talk about mining because I think there's a few confusing ideas around Bitcoin mining and the consensus protocol and what is really going on behind the scenes with the Bitcoin network. So I urge everyone to take a stab at the Mastering Bitcoin book. It's free on GitHub, or you can download or order the paperback version. But we're going to go through this, and I think this first part's really important. So when you hear the word Bitcoin mining, what you might think of is, guys under the ground trying to extract precious metals, or maybe an oil platform trying to extract gas or oil from beneath the seabed, whatever they're going. But really, it's somewhat of a misnomer. And this is how he starts this paragraph. It's misleading because the focus of the word mining makes you think of the reward for mining and the Bitcoin that's created in each block. But this is really the incentive, and this is the reward. But the primary purpose is not the reward or generation of coins. What really is happening, it's the mechanism that underpins the decentralized clearinghouse. What does he mean by that? Well, what's really happening here is mining, and the miners are securing the Bitcoin system. And it is enabling this emergence of a network-wide consensus without a central authority. So the incentive system of mining is actually providing the security of the system without having some central authority validate the network, right? So I love the tip here. It's very simple. Purpose of mining is not the creation of new Bitcoin. That's the incentive system. The mining is the mechanism by which Bitcoin security is decentralized. So what's going on here? I'm just kind of at a high level because I think this is really helpful. He really goes into depth, step by step, of what's going on here. Well, if Joe and Alice, say, want to send Bitcoin to each other, Joe's wallet will actually create the transaction and everything that goes into that transaction. And once that information is complete, that transaction, which is a little piece of a file, small piece of data, will then be broadcasted to its nearest peers in the network, nodes, and then those nodes will share to their peers, and this is shared across and propagated across the network. So what happens is, as miners or nodes, we'll call them miners, validate these transactions, they're really going to go validate whether they're valid, they're correct, check them, and then they're going to compete to add their local version of a block to the Bitcoin network. I always thought there was one single block being competed for, but that's not really the case. There's actually as many versions of this candidate block as there are miners, right? So there are two types of rewards in return for providing this security or this validation. That is the block reward or the Coinbase reward, and then the transaction fees from all the transactions included in the block, right? So in order to earn this reward, they then compete to solve a difficult mathematical problem, right? And that is called the proof of work. And that's included in that next block, which is then it acts as proof that miners expended their computing effort. And the competition to solve this algorithm and to earn the reward and the right to record their transaction on the blockchain is the basis for this security model. So it's really, really interesting. And then that reward, changes over time. And they also earn fees, so they go into the economics of that reward system and why that goes down over time. But I'm really interested in really like the step-by-step here, right? And really what's interesting here is, how can everyone in the network agree on the universal truth about who owns what without having to trust everyone, right? In traditional systems, you might rely on a bank to do that. But there needed to be a system in which everyone could actually have a truth without one person having control over the entire public ledger. And this is how this incentive system achieves that, which is really cool. So it emerges at the interplay. This decentralized consensus emerges from the interplay of four processes that occur independently on the nodes. So remember, each independent node has its own version of the block chain, right? And it's competing for that next version. So what happens here? As the transactions come in, they independently verify its transaction, and then they aggregate these transactions into new blocks by the mining nodes, right? There are specific nodes that are special nodes called miners. And then, of course, they demonstrate the computation through proof of work. And then once they've solved that, if they do, they then send that block to their peers. And then there's independent verification of the new blocks by every node. So every node says, oh, yep, I see that this block was solved. The proof of work algorithm was solved. And then what happens is the independent selection by every node of the chain with the most cumulative computation demonstrated proof of work. So they're looking for the latest chain, right? So he goes through this actually. So as transactions come through, right, and anyone can broadcast a transaction, each miner goes through an actually not small list of checks against every transaction. And this is in the Bitcoin Core code, right? The more important things to consider here is whether that address has enough Bitcoin to send to the other address, right? And so forth. So these miners are doing a lot of work here. See, here's a simple check. Sum of input values is less than sum of output values. They're doing a lot of work here to check that these transactions are valid. If they come through and they're not, they reject them. And over time, as all of the nodes receive these transactions, they will reject them, right? And these functions are done right within the Bitcoin Core code, right? They're all here. So anyone can get this when they download Bitcoin Core. And then what happens is it goes through specialized nodes called miners, right? And this goes through the process by which a block is built, right? So in this example, there's a person named Jing. Jing's node is listening for new blocks propagated on the network, as do all nodes. However, the arrival of a new block has special significance for a mining node, right? Once a new block is confirmed to the proof of work algorithm, what happens is the Jing's node will then start the process by which a new block is created. And this is what happens next. So after the validates transactions, the Bitcoin node, each individual Bitcoin node will create a mempool or memory pool, often called mempool, and where the transactions await where they can be included into a block, right? So there's a lot coming in. They all can't fit into the block, and you might order them by transaction fee amount. And so the transactions come through. Jing then aggregates these into a block, right? Into the memory pool, and then starts to work on a new empty block called a candidate block, right? And so now there's a candidate block, and this goes through the process by which one is created. And as that block is created, a first transaction is always created, and this transaction is called the Coinbase transaction. And this is a special transaction that essentially is the reward from mining that block, right? So every individual node is creating a candidate block with that potential reward if they eventually do solve the proof of work algorithm. And this is the process by which this happens. And that Coinbase reward is actually calculated in each individual block. And there is the get block subsidy function, which is quite a little infamous in the Bitcoin community. This is the very simple formula for determining what the current Bitcoin reward is. And it looks at, well, how many halvings were there, and it takes the initial one and divides it by how many blocks have occurred, and you eventually get the current Bitcoin reward, right? And it goes into what's really going on there. And then there's a standard structure for that Coinbase transaction. Some data that would go into that Coinbase transaction and the block header. This gets a little bit in a little deeper, right? And so once that's created, you have the candidate block and the Coinbase transaction. Well, now it's time to mine the block. It's time to try to solve the proof of work algorithm. And in the simplest term, it's the process of hashing the block header repeatedly, changing one parameter until the resulting hash meets a specific target. So they're basically guessing numbers. And if they finally do guess that number, it's a very difficult number to go and guess. Well, then they are rewarded that block, right? And so this goes into the proof of work algorithm, right? You can really deep dive into how that's happening. But he goes into essentially the process by which all of these numbers are guessed. It's almost like throwing dice repeatedly until you guess an output value that matches what the solution would be. So if an individual miner guesses and successfully mines this block, right? Well, that candidate block, what happens is you basically put the solution for that into the block header, right? And then you take your block and you transmit that block to all of its peers. So again, there are thousands of nodes with their individual candidate blocks all working on the next block, right? And they will only stop work on that if they receive a valid block with the proof of work solution in it. And then they can validate that quite easily. It's very hard to solve, but it's easy to verify, right? And so there's a process by which that block is then validated by each individual node, right? If it's not valid, if say someone tried to stuff a bunch of incorrect transactions in a block, well, the next node will just reject it, right? It'll be very hard for someone to go and send that an invalid block through the network, right? And so it goes through a process by which it checks, right? The block data is correct, the timestamp looks good. There's the first transaction is a Coinbase transaction. There's a standard block here, right? And then once, if that is valid, it continues to propagate through the network, and then you start to assemble the chain of blocks into the network. So you can read more about what would happen if you forked a network and what would happen if there's rejections of nodes and perhaps competing versions of the network, and then the hashing rate and stuff like that. But over time, he really gets into the total hashing rate, which is a good proxy for the security of the Bitcoin network, is increasing over time, right? As more and more miners or hash power add to the network. So there's the growth of mining pools. So there's a lot to go in here, but I think this is I do encourage you to at least go through the first top part here and learn how each individual version of the candidate blocks are constructed, then validated, and then chained on to the next blockchain version, and then validated in the network. So I'll stop here. This concludes for the mining video, and next we'll go into maybe transactions and so forth.